Hello, pre-algebra students. This is chapter 4.7 on scientific notation. In earlier chapters, we learned to use properties of exponents. Now we're going to learn to write numbers by using scientific notation. Let's begin. Scientific notation is a very specific way to express large numbers. A number is written in scientific notation if it has the form c times 10 to the nth power, where c is greater than or equal to 1 and is less than 10, and n is an integer. Let's work through some examples where we convert a number to scientific notation. When working with scientific notation, you'll need to understand 3 different forms in which we can write a number. Here are 2 examples of a number in standard form. 725,000 is in standard form. 6/1000 is also in standard form. We can also write these numbers in what's called product form. 725,000 in product form would be 7.25 times 100,000. 6/1000 in product form would be written as 6 times 0.001. Now we can convert these numbers to scientific notation. We'll take the product form, 7.25, multiply that times 10 to the 5th. The 5 representing 10 times itself 5 times, which gives us 100,000. 6/1000 written in scientific notation would be 6 times 10 raised to the negative 3, or 6 times 1 over 10 cubed. Let's work through a couple more examples where we convert a number from standard form to product form and then into scientific notation. So the retina of your eye has 120 million rods. Write this number in scientific notation. Okay, so we'll begin by first moving the decimal point 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, giving us 1.2 times 100 million. Now let's convert that to scientific notation. We keep the 1.2 times 10. How many times do we have to multiply 10 by itself to get 100 million? The answer is 8. Do you notice a pattern here? That's also equivalent to the number of zeros. 1, 2, 3, 4, 5, 6, 7, 8. That's a good general rule to follow. You can count the zeros and use that as your exponent. So 120 million, written in scientific notation, is 1.2 times 10 to the 8th. Let's try another. The thickness of the human retina is 0.00012 meters. Let's write this in scientific notation. First, we need to write it in product form. To do that, we need to move our decimal point 4 places to the right. 1, 2, 3, 4. Giving us 1.2 times 0.0001. To write this in scientific notation, we'll now take 1.2 times 10 to the negative 4. Once again, notice that our exponent is the same as the number of zeros, 1, 2, 3, 4. This time, however, we're using a negative exponent to show that this number is less than 1. It's actually representing 1 over our quantity. Now let's switch this process. Let's start with a number in scientific notation and change it to standard form. 3.2 times 10 to the 7th. The first thing we'll do is we'll convert this to product form, which will be 3.2 times 10 times itself 7 times. You can use a quick shortcut here of using 1 and then adding 7 zeros, which gives us 10 million. So 3.2 times 10 million. So the standard form of this number will be 32 million. Okay? Let's try another. Let's take 8.69 times 10 to the negative fifth, and let's write that in standard form. The first thing we'll need to do is write it in product form, which is 8.69 times 0.00001. We have 5 zeros total because our exponent was 5. Now convert this to standard form, which will require us to move our decimal point 5 places to the left. So our number will become, let's see here, it will be 0.0000869. All right, there we go. Now try a few of these on your own. For problems 1 through 4, express these numbers in scientific notation. Press pause while you work, and there will be 4 more problems when you come back. For these next 4 problems, please write the numbers in standard form. Press pause while you work, and when you come back, we'll learn to order numbers by using scientific notation. Okay, folks, our next task is to learn to compare numbers that are written in scientific notation. So we're going to order 3.9 times 10 to the 6th, 3,800,000, and 4.2 times 10 to the 5th, from least to greatest. So our first step will be to make sure we're comparing apples to apples. We need to write all of our numbers in scientific notation. 3.9 times 10 to the 6th is ready to go. 3,800,000 needs to be written in scientific notation, which would be 3.8 times 10 to the 6th, correct? Because it would be 3.8 times 100,000. And then our final number is already in scientific notation for us, 4.2 times 10 to the 5th. Our next step will be to order the numbers with different powers. As we know the powers tell us how many zeros are after our number, it'll automatically tell us which of our numbers is the smallest. So 10 to the 5th is going to be less than 10 to the 6th. So we know that 4.2 times 10 to the 5th will be less than either of the numbers that are 10 to the 6th. Now we need to order the numbers that have the same power of 10. 3.8 is smaller than 3.9, so it comes next. 3.8 times 10 to the 6th. And finally, 3.9 times 10 to the 6th. Then we need to rewrite our sentence with our numbers in their original forms. So now it will be 4.2 times 10 to the 5th is less than 3,800,000 is less than 3.9 times 10 to the 6th. And we're done. Now please do the work of ordering each of these sets of 3 numbers on your own. Press pause while you work. We have one final problem to do together before you're finished for today. In our final problem today, we will multiply numbers in scientific notation. A Wolffia plant is the smallest flowering plant in the world. One Wolffia plant has a mass of about 1.5 times 10 to the negative 4th grams. At least 5 times 10 to the 3rd Wolffia plants would fit in a thimble. Isn't that wild? So what is the mass of 5 times 10 to the 3rd Wolffia plants? So the total mass is going to equal 1.5 times 10 to the negative 4th times 5 times 10 to the negative, or 10 to the 3rd. So what on earth do we do to multiply these two numbers in scientific notation together? First, we have to use the commutative and associative properties of multiplication. Remember what that means? That means we can rearrange this problem, because everything's multiplied by everything else. So it doesn't matter in what order we do the work. So let's group likes together to make our job a little easier. 1.5 times 5 times 10 to the negative 4th times 10 to the 3rd. Just got a lot easier, didn't it? Now let's begin solving. 1.5 times 5 equals 7.5. And we can use the product of powers property to solve 10 to the negative fourth times 10 to the third. So our final answer will be 7.5 times 10 to the negative 1 gram. Or, if we're going to write that in standard notation, a thimble full of Wolfia plants will be 0.75 grams. All right, that wraps it up for today, friends. I'll see you tomorrow for more practice in working with scientific notation.